Good afternoon. My name is Adam Rutz. I'm the wastewater treatment and reuse superintendent at the Big Sky County Water and Sewer District in beautiful Big Sky, Montana. I'm here today to talk to you about our water resource recovery facility upgrades project that we just completed this past year. As you may know, Big Sky is a popular tourist destination. It also has a growing population due to increased development. There are 300,000 annual visitors to the area. There's 3,000 full-time residents in Big Sky and 2,600 connections in our district. Our facility is 100% consumptive. We have no surface water discharge permit, which means that we utilize reuse opportunities to dispose of our reclaimed water. We make compost with our biosolids from the treatment process as well. This project spanned 6 years, 4 years on the build side with 2 stages of construction. The liquids handling component was completed in April of 2024, while the solids handling component of the project was completed this past December of 2024. $60 million total project cost. We elected to install a state-of-the-art membrane bioreactor, which is a tertiary membrane filtration unit post-biological treatment, produces high-quality effluent, is very efficient, and has a smaller footprint compared to most conventional wastewater treatment plants. One thing that's unique about this project is the district elected to pour concrete for phase 2 process basins, which essentially doubles our flow and sets the district up for decades to come. Class A-1 effluent is being produced, which really opens up our beneficial reuse options. Our reuse options have been expanded with the implementation of this MBR. Historically, we've used irrigation and snowmaking as our primary means of disposal. Now we have the option to potentially look at groundwater discharge and aquifer recharge. I noted the facility has been designed for scalability. This project really represents a community investment, environmental responsibility, and sustainability. Initial results off the MBR are showing that we're seeing a 75% reduction in total nitrogen, as well as a 95% reduction in total phosphorus in our reclaimed. The water from our collection system enters our headworks building first. This building functions to remove all the undesirables from the influent waste stream and essentially protects all of our downstream equipment. We have 5 sets of screens in this room that take out this material, as well as a grit removal system. There's then a wet well that holds this screened influent that pumps it up to our process. Following screening in the headworks, we have 3 process basins that provide our biological treatment. There are 7 zones per basin: an anaerobic, anoxic, swing, and aerobic zones. These zones allow us to facilitate different conditions for optimal nitrogen and phosphorus removal, with the added benefit of swing zones that allow us to operate in either an anoxic or aerobic condition based on current nitrification we are seeing. We also have a return stream of activated sludge from the membrane tanks. The mixed liquid from the treatment process basins then enter the membrane tanks where the magic happens. The membranes consist of 0.04 micron hollow core fibers. There are 6,800 fibers per rack. One rack is shown here with 13 modules, and there are 390 modules total in the facility. Flow is driven by a pressure drop across the membrane surface. Transmembrane pressure is monitored. Pressure drop is generated by a filtrate pump that pulls a vacuum on the membrane fibers. A continuous transport of mixed liquor from the treatment process occurs across the membranes. Particles are retained on the outside of the membranes. Permeate flows through the hollow core fibers via the vacuum generated by the filtrate pump. Retentate on the membranes is returned to the treatment process as activated sludge, or is sent off to our aerobic digesters via wasting. Membrane health is assessed by monitoring TMP and permeability values. Air scour, regular scheduled relaxation periods, and cleaning events occur on a weekly, quarterly, and biannual basis to combat organic fouling as well as inorganic fouling. There's a few images of the membrane racks as well as the filtrate and return activated sludge pumps. Here's a view of our blower room that utilizes high efficiency units that feed the process basins with dissolved oxygen. In this room we have our air scour system for the MBR as well as a compressed air system for our pneumatic valving throughout the plant. Our chemical room contains all of our chemical pumps for our sodium hypochlorite cleaning events, our citric acid for our cleaning events, a carbon source for nitrogen removal assistance if needed, as well as aluminum sulfate for phosphorus removal if we need it. We have a state-of-the-art motor control center. We have variable frequency drives controlling all the equipment. This saves us energy, improves efficiency, and extends equipment life. As previously stated, we have no discharge permit, but we are bound to a nutrient management plan that monitors total nitrogen loading to our irrigable areas. Our nutrient management plan pertains to our irrigable areas on the Boyne Meadow Village Golf Course. That plan specifies 108 pounds per acre per year that we can load onto that turf. In our first irrigation season after the MBR was online and during startup, we saw nearly a 2.5 time reduction compared to the previous year prior to the plant being online. This significant reduction demonstrates the profound impact of the new WRF on nitrogen loading to the Meadow Village Golf Course and further protections of the upper Gallatin River watershed. Thank you for listening.